So before starting with the next example, let's look at one more problem that there are several in the homework like, where again not everything is going to come out to be a perfect square under the radical like the first few examples that we've looked at. So let's take a look at a function f of x equals 6x squared plus 3x minus 2. And let's again find the x and y intercepts for this graph. So again, the y-intercept in this form is the easier one to find because we're just going to put an input of 0 and it's already been solved for y. So if we input 0 for x, we're going to get a negative 2. We'll get 0 plus 0, subtract 2, so we'll get negative 2. But to get our x-intercepts, again, we need to solve an equation that looks like this. And we're going to put in 0 for y and see what x values give us an output of 0. So again, to use the quadratic formula, we need this to be 0, and then the coefficient on x squared is a, coefficient on x is b, and our constant term is c. So in this case, we've got a is 6, b is 3, and c is negative 2. So when we put these through the quadratic formula, we're going to get x equals the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. So the opposite of 3 is negative 3, plus and minus the square root. 3 times 3 is 9. And in here, 4 times 6 times 2, we're going to get 24 times 2, 48, and positive. And 2 times 6 is 12. Okay. So here we're going to get x equals negative 3 plus and minus the square root of 57 over 12. Okay, so 57 is not one of our perfect squares, and in the homework we are asked to leave some of these exact, so we can't give this as some rounded decimal. So that means we can rewrite our two x values. We've got negative 3 minus the square root of 57 all over 12, and we've got negative 3 plus the square root of 57 all over 12, which if we put them together for our x-intercepts, those were the inputs that gave us an output of 0. So we've got one x-intercept at this point and another x-intercept at this one. Okay, so some of your answers will have radicals still in them when it asks for an exact answer, and what's under the radical is not a perfect square. Okay. All right, so now let's jump back and look at a problem now that has data. So annual consumption of bottled water has been increasing since 1990, and we're asked to use the given data to answer the following. So these are the years and gallons of water in billions, and we're asked to make our input variable here years since 1990. So again, if we subtract 1990 from all of these, we're going to get 0, 5, 10, 15, and 20. So we're asked to identify the explanatory variable and the response variable. So in this case, we're trying to use the year, or in this case, years since 1990, to try to predict how much was being used in bottled water. So the annual bottled water consumption. So again, remember, we're using the explanatory variable to try to predict the response variable. So we're asked to input their data and make a scatter diagram. So on our calculator, we're going to quit that from the last one and clear that off. All right, so we're going to go into stat 1, and we're going to go over to L1 and clear down arrow to get rid of that data. Then we're going to go over to L2 and hit clear down arrow to clear that data. All right, so in L1 we're going to put 0, 5, 10, 15, and 20. And in L2 we're going to put 2.2, 3.1, 4.7, 7.5, and 11.4. Alright, so I'm going to go into the y equals screen temporarily because we did type some things in there that I don't want to screw up our screen. So we're going to clear out anything that we have on that screen. And then we want to make a scatter plot, which is a stat plot. So we're going to hit second function y equal. And again, make sure plots 2 and 3 are turned off. And we're going to go into plot 1. And we're going to hit enter to turn that on. And then we're going to highlight this first graph as our scatter plot and hit enter to change the highlighted region in case it was somewhere else. And then our X list is L1 and Y list is L2. And then we're going to hit zoom and 9. Okay, so here's our graph. Okay, so it looks like part of one of those parabola type looking graphs that we've been studying in this particular part of the unit. Okay, so on here we kind of had some data that look like that. So looking at the scatter diagram, it does look like a parabola, a quadratic model would fit better. Okay, so remember the graph here would be a parabola, where a linear model, the graph would be a line. So now we're asked to graph this function in that same window. Okay, so we're going to go back to our calculator, which I think I just accidentally closed. So we're going to push y equals, and we're going to type in the equation that they've given us, only we're going to replace the t's with x's for our calculator. So we're going to put in here, let's see, 0.021 x squared plus 0.04 x plus 2.25. And again, we're going to push zoom 9 for the stat graph piece that was there. And so we can see that that graph that they've given us does model our data very well. And so we got, our graph here kind of did fit our data really well. Okay. So predict when the annual consumption will reach 14 billion gallons using the quadratic formula. So this 14 billion gallons is a value of y, or in this equation was our c. Okay. And we want to know when, so that means x is what's in question, or in this case t is what's in question. Okay, so we want to know when this 0.021, t squared or x squared plus 0.04x plus 2.25, we want to know when that's going to reach 14. Okay. Well, if we're going to use the quadratic formula, we need this to be 0, and in this case it's not. Okay, so the first step we need to do is we're going to subtract 14 from both sides of this equation. So that is going to give us 0.021 x squared plus 0.04x. And here we're going to get negative 11.75 equals 0. Okay, so now to use the quadratic formula, we need a 0 on one side, which we now have. And so our coefficient on x squared is a, our coefficient on x is b, and our constant term here is c. Okay, so if we plug those into our quadratic formula, x is the opposite of b, give or take the square root of b squared minus 4ac all over 2a. So like I said, once we start dealing with real-world data, these coefficients are never as nice as they are in the made-up problems that we started with in the unit. Okay, but we've got our calculator to crank through some numbers here. So the opposite of 0.04 is negative 0.04. And under the radical, if we key punch this, we're going to get 0.9886. And in the bottom, if we multiply, we're going to get 0.42. So if we round off, so if we take negative 0.04 minus the square root over 0.042, we get about negative 24.63. And if we take negative 0.04 plus this quantity divided by 0.042, we get approximately 22.72. And in the homework, they're going to tell us to round these to the nearest year. So this is about 23 years after 1990, okay, which would be the year 2013. So then we're asked to predict when the annual consumption will reach 14 billion gallons using our calculator graph. Okay, so if we're looking at that same equation that we started with, we wanted to solve for x, where we had 0.021, and I'm going to replace the t's with x's, 0.04x plus 2.25, oops, equals 14. So to solve using our calculator graph, we're going to put the left side of the equation next to y1 and the right side of the equation next to y2. So if we go into y equals, and we've got 0.02x squared plus 0.04x plus 2.25. And next to y2, we're going to type in 14. And again, we're going to use Zoom 9 because that's where our data was. And then we'll adjust from there as needed. Okay, so in our window, our x max went out to 22, so let's try maybe pushing that out to 40. Zoom 0. Alright, so now we can see our intersection on screen. So we're going to hit second calc, 5, enter, enter, enter. And we can see that we get, there's our 22.72. And this tells us that that is where it reached 14. Okay. So on here we've got our x in this way was also about 22.72. Okay, so we end up with, again, the same answer we got here.